Hello and welcome to my YouTube channel. Today in this video, we are going to implement a simple project using DMA, and in this example, we are going to transfer data from one memory location to another memory location. This project again will be implemented on STM32F44 6RE microcontroller. So let's start the video. From the previous video, you might have learned that DMA is a device which allows data transfer between memory to memory, memory to peripheral, and peripheral to memory without the intervention of CPU. That means it allows the CPU to complete some other important task rather than moving large chunk of data from one location to another location. This improves the performance of the overall system. In this example, we are going to move a small array of data present in one memory location to another memory location. So let's try to see how we can implement this using STM32F44 6RE. So here we have the IDE. First we can go to File, New, STM32 project. This will take few seconds to upload the CubeMX perspective. So here we have to first select the board or microcontroller depending on your choice on which you want to develop the project. So in my case, like always, I will go for Nucleo F44 6RE microcontroller board and then click next and then give a name to the project. So memory to memory DMA and then click finish. Initialize all peripherals with their default mode. No, we don't want to initialize all the peripherals in their default mode. This will take us to the CubeMX perspective, where we will have to initialize the peripherals using the CubeMX perspective. Here we have all the peripherals. Now we are going to pin out and clear all the pinouts. So basically, this will clear all the pins definition and everything from the STM32 CubeMX perspective. So click yes. Now we have the raw IC in which no peripheral is initialized with any particular value. So in this project we are going to use DMA, okay, to move data from one memory location to another memory location. So if you go to system core DMA, you can see there are DMA 1, 2 and memory to memory DMA. So how can one identify which DMA to be used? For that, one can use the reference manual, and I would request you to download the reference manual RM0390 revision 6 from the STM website. Now after opening this, you can go to the chapter 9 related to direct memory access. If you scroll down, you can come down and see that it has got, this microcontroller has got 2 DMAs with 8 streams. Further coming down, you can see the different functioning blocks. And the features of the two DMAs. For example, DMA1 requesting map, DMA2 requesting map, which peripherals are connected to which channel and which stream. Further scrolling down, you can see the roles of arbiter, which configures the priority of the DMAs or the streams. And then coming down, you can see the register which controls the direction of data transfer, like peripheral to memory, memory to peripheral, memory to memory, and so on. So we are interested in memory to memory data transfer. So scrolling down, we can reach to page number 211, which talks about memory to memory mode. In this, please go through this section, and here you can see one very important statement. It says only DMA2 controller is able to perform memory to memory transfer. So that means we have to work with DMA2. So we can go to DMA2 and then configure the DMA for memory to memory transfer. So just click add, select memory to memory, and in this window you can see all the configuration related details, like the DMA will work in normal mode, so there is no circular mode available in this DMA, and we are going to transfer data from one source memory to destination memory. Data width will be byte and burst size will be single. This is all we need to configure. We don't have to change anything. We are not going to change the priority and all, because we are using only one DMA, so priority we can keep low. Then click on the gear button on top, device configuration tool code generation. This will allow us to generate the code. So now we have the code with us, and we can write program to transfer data from one memory location to another memory location. For that, first of all, I would like to close or collapse all the windows. So just right click, go to folding and collapse all. This will save a lot of space and you can work on a particular function. So first of all, let me go to the section where I can add the variables. For that, I can go to private variable section, click here, okay, private variable section. Here I will go for uint underscore uint8 underscore t, and let us make an array to store few data. Let us keep 0, 1, 2, 3. Okay, so this is our array, and we can call it source array, and uint, and let us call it destination. And let us give a space of 10. So let me call it source. Okay, source and destination. So the source array contains 10 input variables or 10 values, and destination is the location where we will try to transfer all this data using DMA. Let us go down in the main, and in the main you can just go to user code begin to and use the functions related to DMA. So DMA underscore start. Okay, pass the handle. So handle is memory to memory DMA to stream 0. Now for the source we have to write source. Okay, and let me typecast it. Wait a second, let me typecast it to uint 32t, and for destination address we can again use uint 32 underscore t bracket close and destination. And what is the length of the data? We know that source contains 10 data in it, so the size is 10. This is all we need to do to start the DMA. So all DMA start, let me take it back. Okay, all DMA start, pass the handler and then source, then destination and the number of elements or variables that you want to pass. Okay, and then we can use while function to just check whether the whole DMA, okay, all DMA polling of the memory to memory handler and what level we want to complete. So for that you can just select the function, go to open declaration, and here you can see all the parameters that we can pass. So first is the parameter pointer to DMA handle type def structure. Second is complete level specification, and then we need to pass the timeout also. So for completion or complete level specification we can just pass here HAL DMA underscore full data transfer. So until the full data transfer takes place it will keep on polling, and let us keep a timeout for 100 millisecond equal to all underscore okay. So this will keep on checking if the Hall's transfer takes place or not, and this is all we need to write on the program. Done. Now let us try to compile the program and see if everything goes okay or not. So let me just editor appearance. Okay, seems it has changed the. Now let us try to build the program. For that you can just click on the hammer button and see if there is any error or warning. So there is no error, no warnings. Let me connect the microcontroller board and debug the program. So go to debugger, debug configuration, STM32, and here memory to memory DMA debug. So go to debugger and click debug. Now here in the live expression view we can just add the variables like source and destination. So source and destination. So here we have the source and destination array, and we can see right now the source contains all the values which are there in the array like 0, 1, 2, 3, 4, 5, 6, 7, 8 and all, whereas destination right now contains all zeros. So here in this case, the DMA will transfer the data from the source location to the destination location, and you can see we are not entering into the while loop, and this transfer will take place using the DMA. So CPU will not be involved in this case. Let us run the code, and we can see the data has been transferred from the source to the destination. We can pause the program, and we can see here the program is waiting in the while loop. Even if we continue to run the program will remain in the while loop. And here we have demonstrated the use or feature of DMA to transfer data from one memory location to another memory location without using or without any intervention from the CPU. I would stop the program, and with this I would like to end the presentation. And if you have not subscribed the channel, then I would request you to please subscribe the channel and press the bell icon so that you will get the notifications as soon as I upload a new video. If you have not liked the video, then I would again request you to please like the video. If you have any doubts or suggestions regarding this video or any other video, please share your doubts and suggestions in the comment section. Thank you and have a nice day.